Okay, let's take it up a notch here. Now we'd like to identify that as, again, one of the famous identities. So you have your choice. You could think, well, wait a minute. Let's go with that. Can you see? Yeah, you can see. Does this look like 1 minus a cosine squared theta? Does it look like 1 plus a tangent squared theta? Does it look like 1 minus a sine squared theta? Does it look like secant squared theta minus 1? Often it's one of these guys, and every one of these guys is special because they all turn into a monomial, and everything would be nice. Wouldn't it be nice if that was the square root of a monomial instead of binomial? Because then we could easily take the square root of it. That's the idea. It most resembles, not this one, because this one's got the constant minus the square. Wait, yeah, it does resemble that one, or this one, this 1 minus the sine square. Either one of these would work. Not that one, because both of these are positive. Not this one, because the variable is the one that's being squared minus 1, not 1 minus the variable squared. So it wouldn't be that one. In this case, this one would successfully get the job done, as well as that one. There's no, and you could use either one. The answer at the end may look different depending on whether you do it that way or that way, but they would be equal, except maybe for a constant, which is expected when you do integrals. Somebody may have a different constant at the end. Alright, talk is cheap. Let's do it. I'm going to try to match this one, so I want my dictionary to be like this. I will draw my dictionary in green. So I want 1 minus x squared to be translated to be exchanged for 1 minus a cosine squared theta. That's what I want, and that's what I'll get. So that means that x squared should be equal to a cosine theta. That means that x should be equal to cosine theta. The differential dx would be equal to a sine theta d theta. And this is my dictionary right here. Sometimes you need another part of the dictionary where you need to draw your right triangle. Cosine, of course, is the ratio of adjacent over hypotenuse. So you could write that as a ratio and say, okay, just in case I need it, cosine is x over 1 theta. I could use Pythagorean theorem to complete this. This would be 1 minus x squared, just in case I need my more pieces of my dictionary. Alright, talk is cheap. Let's do it. So we do the integration. I will continue with the integration here. So that integral of 1 over the square root of 1 minus x squared dx becomes integral of 1 over the square root of 1 minus x squared, we said was 1 minus a cosine squared theta. Dx, we said, was equal to negative sine theta d theta. This becomes, I could pull out that negative, this becomes sine theta d theta. On the bottom, this becomes the square root of sine squared theta. Look at that. Isn't that nice? Turning into monomial. Life is good, right? Now, of course, the square root of the sine, assuming it's positive, would cancel that one. And that would become d theta, which would become negative theta plus a constant. You're basically done, except you should convert your thetas to whatever it was originally asked. You know, the variables that were asked were in terms of x. You should answer with x's. So we go back to the dictionary here. The dictionary says this is theta. Cosine theta is equal to x, so x must be the. So theta must be. Let me make sure. Okay, here we go. So theta is equal to arc cosine of x plus a constant. That does it. Isn't that nice? I told you, it's easy. Turning binomials into monomials. Powerful stuff.